This is a look at some of the questions from the Chapter 1 Cluster 2 pre-assessment. So I had a couple questions about this one. The first one, question 1, was asking us to determine the average rate of change between 1950 and 2010. So we're specifically looking at the ordered pairs 1950, 22.5 and 2010, 27.8. So I can go over to decimals window and I can set up my rate of change. Difference in the y coordinates, so 27.8 minus the first y coordinate, so final minus initial, over, and the 2010 and the 1950, we're probably counting from 1900 here. I'd have to look down and see if I'm counting since a certain year. But for this case, I'm just going to go ahead and use the full year value because the starting year will subtract off anyway. So this comes out as 0.0883, and that was the desired answer. So we're looking at the rate of change specifically between the 2 years mentioned, 1950, 22.5, and 2010, 27.8. So final minus initial in the output over final minus initial on the input, outputs on top. Okay, so that's what we were looking for in the first question. The next one we need to take a look at is number 5. And number 5, it's asking about horizontal intercepts. So I'm going to go ahead and take a look at this equation real quick. I believe that when you worked on this one, you were thinking about it graphically. And so we can see that the horizontal intercept is at the ordered pair 0.8333, 0. However, this question is not set up to accept a decimal solution. It would like it to be an ordered pair using integers or fractions, as it says here, for any numbers in the solution. So I can solve this by hand as well. If I want to find the horizontal intercept, we're going to substitute 0 in for the y value. So 0 equals negative 6x plus 5. I'm not going to graph that. I'm just trying to write down what I'm trying to do, plugging in 0 for x. And then I would need to, let's say, since this is a negative 6x, I could add 6x to both sides. And again, I'm not trying to graph something right here. I'm just trying to show my algebraic steps right here. So I'm adding 6x to both sides. And then I would divide by 6. So 5 divided by 6 for x. And again, I'm not trying to graph. I'm just trying to figure out what this number is. So 5 divided by 6, 5/6 is the simplified fraction for that value. And so that's why we have our 5/6 as our x coordinate, 0 right here. So by hand, if you want to find the horizontal intercept, y needs to be 0, plug in 0 for y, solve for x, and you can get the fractional coordinate for that value. I believe that's the same thing that might have happened here in number 14. For this one is actually vertical intercept, but if I pull up my decimals graph again for this one, the equation is 2x minus 3y equals 11. And you can see again that the vertical intercept is not at a whole number. So it is 0, negative 3.667. Which was what was entered here, but we want to enter it in an exact value. And so we would take this equation and we would solve it for y. It looks like you may have already done so. And when you solve it for y, you can see that your slope is the 2/3 and the negative 11/3 is the y coordinate of the y-intercept. So again, it doesn't say round to something, so don't round. Use a fraction, use an exact value unless you're told to round to a certain number of places. In most of the non-contextual examples where we don't have a story problem to go along with it, fractions are preferred as our coordinates here anyway.